So today what we're going to be working on is that we are going to figure out how to solve simultaneous equations. Now this is in chapter 4, linear equations, and we're going to be going through two chapters, both 4.5 and 4.6. In 4.5, we're going to be dealing with the first method, which is called substitution. And then we're going to be dealing with the second method, which is called elimination. So first we're going to deal with the branch, which is chapter 4.5, substitution. Now, what are we going to be doing here? The best way for me to describe this is actually just using an example. So I'll go with, as the textbook is using, the two equations, y equals to 2x minus 4 and 3x plus 2y equals to 6. Now, in this equation, when we're looking at it, we can tell, we're given y here is equal to 2x minus 4. And that is the same y here. Now, we'll get into the meaning of these equations a lot later down the track. But right now, we just want to think fundamentally. If all these yellow blobs are the same, that would mean that we can say then 3x plus 2 times 2x minus 4. Now, where did I get this from? Here, this is the same yellow blob. Because it's the same, because this is equal to this, and because then we can say this is equal to this, we can actually take 2x minus 4 and put it in brackets. And then we'll just finish off the same equation, equals to 6. So now we can see that continuity. And then we can just expand it out, saying, okay, 3x plus 4x minus 8. So here I'm just expanding the brackets here and here. And then we can say equals to 6. And then we can just simplify it. 7x minus 8 would equal to 6. 7x would equal to 14. Hopefully you can tell that simplifying this to get 7x. Then I'm moving minus 8 to the other side to get 14. X would equal to 2. Then we take this equation and substitute it into here. Because now we know x is equal to 2. We can say, therefore, y is equal to 2 times 2 minus 4. Because again, x is equal to 2. We're substituting in here. Then y would equal to 4 minus 4, which would equal to 0. So then we can tell x is equal to 2, y is equal to 0, and that would be the answer. So that's the first method of substitution. Second method, what we're going to be dealing with, is called, before we move on to elimination, there's another kind of substitution which the textbook gives us, and it's actually a really good one. So let's just say that we have y is equal to 4x, so we'll do example 2. Y is equal to 4x minus 3, and y is equal to 2x plus 9. In this case, we can see y is equal to something, and that same y is equal to something else. So if you want to think about it like this, if I say that x is equal to 2, let's just say x weighs 2 kilos, and y also weighs 2 kilos, then it's a logical assumption for me to then say, okay, then x and y weigh the same. So in the same manner, what we're going to do is that then we can take it, and then we can say, because this right-hand equation is equivalent to y, and this right-hand equation is equivalent to y, then we can say, therefore, 4x minus 3, so this yellow part, is equal to 2x plus 9. This green part. And then we can then simply just solve. So from here what we'll do is that I'll put 2x on this side. So we'll say 4x minus 2x would equal to, and then I'll take the minus 3 and put it on this side. 9 plus 3. Then I can say 2x would equal to 12. X would equal to 6. Am I done? No. Because even though I know what x is equal to, we need to take it and substitute it into either one of the equations. It won't matter. But just for the sake of an argument, I'll take it and put it in the second one. So again, I know what x is equal to 6. I can then say, therefore, y is equal to 2 times 6 plus 9 equals to 12 plus 9, which would equal to 21. Voila, now we know what x and y are equal to. So now that we've done the first part, we're going to now move on to the second method of solving equations. So here, when do I use this? The easiest time to use substitution is when you can tell that either y is just easily substituted when there aren't any coefficients next to it. When you see like 3y is equal to this, it starts to get a little more messy. And that's when now the second method can be used. Now the second method is what we call elimination. Now this is a little bit more of a complicated procedure. So what I'm going to need you to do is just observe me here. If I take two different objects, here, power bank and phone, right? And if these two weigh the same, this is what an equation is. So if I've got an equation saying that maybe, let's take it from here. So I'm going to take now from 4.6. If I'm going to say that 3x plus 4y equals to 14, and then I can also say that 5x minus 4y equals to 2. Now, in this scenario, I want to consider each equation like a balancing set of scales. So we've got the yellow component of this equation. We've got the green component of this equation. We're going to have the blue component of this equation and the pink component of the equation. Bear with me because this will make sense in the end. Now, what we're dealing with first of all is that when we have a scale, we're going to have the yellow component would weigh just as much as the green component, right? Because on the scale, you're saying that yellow equals to green. Now, we don't care about the variables for now. Just follow with me in the analogy. The yellow component weighs just as much as the green. So, the problem is, if I were to add the blue component, the scales would tip. Because then you're like, wait a second, I've added blue. How would I balance out the scales again? The only way would be to then add the pink to then rebalance the scales, so then it would weigh the same. So if you want to add the pink, then you're like, oh, okay, then we're balancing up again. So this is the general gist of it. So if I were to then say equals to, this is like overall the scale, back to balances, we're going back to basics. Now, what does this mean in practice? If I was to call this equation 1, and if I was to call this equation 2, if I were to try and do process of elimination, what I would do is that I would take equation 1, add it to equation 2, and you'll see what magic happens here. So first one, from equation 2, whenever you're adding equations, you add the left side together, you add the right side together. So this would look like this. If I did equation 1 plus equation 2, and notice my working out, it's really important that you show proper working out. Equation 1 plus equation 2. This would equal to 3x plus 4y. So that here is the yellow part. I would add it to 5x minus 4y. That's the blue part here. But now I've got a really heavy side on the left-hand side of the equation. That's like a lot. So how do I balance it out to then make the equal sign true? I can say that is equal to 14, which is the green, plus 2, which is the pink. Now, do you see how it's now evenly weighted? Because we added all of the left-hand side, but then we also added all of the right-hand side and made it all equal. So that's how now this is okay, we can continue on. So that's the main hard part to grasp your head around. We need to try and make sure that everything balanced is equal. So now from here, what we can do is that we can say, okay, 8x So 3x plus 5x, 8x. And then you've got plus 4y minus 4y. That would cancel out to be 0y. So we'll say 0 is equal to 16, 14 plus 2. Then we can say x is equal to 2. Because I take the 8 down, 16 divided by 8 is 2. X is equal to 2. And then from here, I'll substitute it back in. So then you can say, okay, then 3, 2, so substitution, this is like the first one, plus 4y is equal to 14, 6 plus 4y is equal to 14, 4y would be equal to 8, y would equal to 2. And just like that, you've solved using elimination. Now, the questions can get slightly harder, because then you can think about, what happens if, because here we can tell, it just perfectly lined up. Now, there are a few harder versions. Now, let's just say hypothetically, because the reason why I can add these two together is like, if I add plus 4y and if I add minus 4y, easily gets rid of each other. But what happens if it's presented with a different scenario? Let's just say instead, so I'm just trying to find an example where I can just easily add them together. One where I can subtract them. Nice. Let's take question, so this is 4.6, question 2a. Let's just say hypothetically that equation 1 will be x plus 2y is equal to 13. 5x plus 2y is equal to 23. Here's the problem. If I add them together, I'm just going to be given more mumbo jumbo. Instead, I want to eliminate 2y. How do I do this? Well, if I take equation 1 and if I subtract equation 2, that would be 2y minus 2y. I'm thinking ahead of the game. So then I would label this equation 1, I'd label this equation 2. Now what I can do is I can say equation 2 minus equation 1. Then I can say, equation 2, left-hand side, 5x plus 2y. Right? So that's this part, left hand. Then I want to think, minus x plus 2y. Left hand here. Now the equation's unbalanced because now, the left-hand side is too heavy. So I'll say this equals to 23 minus 13. Because notice, equation 2 minus equation 1. Now it's even again. This same principle which we applied, being that, yes, we have the equation. It's the same thing with subtraction. If you subtract from the left-hand side, it makes it too light. To even it out, you need to also subtract from the right-hand side. That's why this equation holds true. And then from there, it's just a simple process of simplifying. So it'll be then, but there's one very important step. We have 5x plus 2y. This negative, be careful. Don't get tricked. You need to expand out the brackets. This would be minus x minus 2y. Because when you're expanding out the brackets, this is as if you were timesing by -1. People will get tricked by that. You need to expand the brackets out first. Equals to 10, because 23 minus 13 is 10. Then you can say 4x plus 2y minus 2y. That gives you 0. 4x equals to 10. X would equal to 5 on 2. And then what do? You take it, you substitute it. So let's just say then here, 5 times 5 on 2 plus 2y would equal to 23, which would then mean that then 25 on 2 plus 2y would equal to 23. 2y would equal to 23 times 2 is 46. 46 minus 25 on 2, so I'm sending this to the other side, which would equal to 21 on 2. So y would equal to 21 divided by 4. And you can just leave your answer like that. You don't need to simplify it, giving it in decimal points or whatever. So, this is the basic process of elimination. Realistically, I would love for you to just go up to here in terms of homework, try and get all the questions done, make sure you understand everything, and just shoot me back if you have any questions. Please consolidate what we've learned today in this video tutorial and get back to me on your progress. Thank you very much.